Hi, I'm Miss Hearn. Let's get started. In this video we're going to discuss parabolas. And you may be familiar with parabolas from College Algebra or another algebra class. And you probably learned that the typical example of a parabola is y equals x squared, and that y equals x squared has a vertex at 0, 0. It has that classic U shape. It has an axis of symmetry, the line x equals 0, and that we can graph it finding at least one other point besides the vertex and using the symmetry. In general, you may have learned that parabolas are functions of x, and that they take the form a times x minus h squared plus k, where in this case the vertex of the parabola would be hk. And if a happens to be positive, then the parabola opens up, and if a happens to be negative, the parabola would open down. So this is a pretty limited view of parabolas. We're only considering those parabolas which are functions of x. But there are other parabolas. Some are horizontally oriented, and so they might look like this, in which case they're not going to be a function of x, but rather x is a function of y, which is the reason why we don't generally look at them in college algebra. Once we get into pre-calculus and calculus 2, we're going to be concerned about taking a broader look at parabolas. We're going to think of them as conic sections. When I say conic section, I'm referring to any shape that can be constructed by taking a cone with another cone inverted on top of it and slicing through there with a plane. In this case, only through one of the cones, because we're running parallel here to the other. And that shape is going to turn out to be a parabola. You can probably also visualize that if we were to cut through the cone in a different way, that we might get a circle or an ellipse or a hyperbola. And we'll discuss those in another video. In this case, we're focused on the parabola and how we can orient that parabola in different ways in the xy coordinate system. The parabola is going to have the vertex hk. We're going to refer to the x-coordinate of the vertex as h and the y-coordinate as k. But we're also going to refer to a point called the focus, which is somewhere along the axis of symmetry of our parabola, and we're going to refer to a line called the directrix. The focus and the directrix are each the same distance from the vertex. We're going to call that distance p. And they have the very specific characteristic that if you were to look at any point xy somewhere along our parabola and find the distance between xy and the focus, which we'll call that distance 1, and find the vertical distance between xy and the directrix, we'll call that d2, that these two distances are the same. You can see my sketch is not quite accurate because d1 should be equal to d2 if I had my focus and my directrix drawn correctly. Now, much like when we learned about parabolas from a function of x perspective, where we could look at the equation of the parabola and find the vertex and determine whether it opened up or down, we're going to be able to look at the equation of a parabola and determine not only its vertex and which direction it opens, but also the coordinates of its focus and the equation of its axis and directrix. So let's look at an example. So here we're asked to find the vertex, focus, axis, and directrix of this parabola. And the reason that we know that it's going to turn out to be a parabola is we have a polynomial equation with two variables. One of the variables is linear. The y has a power only of 1. The other variable has a power of 2. We can take this equation, which is in what we call general form, and we can rearrange it in such a way that it fits one of two standard forms. So the standard form of a parabola, which is going to have a vertical orientation, opening upward or downward, is going to look like x minus h squared equals 4p times y minus k. Again, this is called standard form. And very similar to the standard form for a vertically oriented parabola, the horizontal standard form is y minus k squared equals 4p times x minus h. Now remember, regardless of which type of parabola we have, h and k represent the coordinates of the vertex of the parabola, and p is the distance between hk and the focus, which I'm going to call f. Now, Before we convert our general form to one of the standard forms, we need to identify which one we're looking at. Notice that in the vertical case, the x is being squared. If you were to FOIL out x minus h squared, you would get an x squared. And that's how we know that right now we have a vertical form of a parabola. But we need to rearrange it so that it fits this format. And that's going to involve completing the square. So we're going to leave the terms x squared and negative 4x on the left. And we're going to move our other terms, negative 8y and positive 28, over to the right by adding 8y and subtracting 28. And then we're going to decide which constant term will we need to add to x squared minus 4x to get a perfect square trinomial. You might recall that to do that, we need to take half the coefficient of x. Half of negative 4 is negative 2, and we need to square it. Negative 2 squared is 4. So on the left side, we need to add positive 4. X squared minus 4x plus 4 equals, but to maintain our balance, we need to add 4 to the right as well. So we have 8y minus 24. Then we're going to factor the left so that it looks like x minus h squared. This factors into x minus 2 squared. And by the way, you always know how it's going to factor by looking at the value you got when you took half. And on the right, notice that we need in parentheses just y minus k. So whatever the coefficient of y is needs to be factored out. So I'm going to factor out an 8 in this case. Alright, we almost have this in the form we want. The next thing we need to focus on is this 4 times p. So how can we think of 8 as 4 times something? 4 times 2. So this is x minus 2 squared equals 4 times 2 times y minus 3. So now we can easily identify that h is 2, that k is 3, and that p is 2. Now, when you're asked to find the vertex, the focus, the axis, and the directrix, and you're not asked to graph, it's still really a good idea to just go ahead and quickly sketch the graph, very rough sketch, because that's going to help you to know how to adjust the coordinates of the vertex to get the coordinates of the focus. You'll know in which direction you're going. So in this case, we know that we have a parabola that has a vertex 2, 3. So let's go ahead and graph that. Really rough sketch. So we have 2, 1, 2, 3. So here's the vertex 2, 3. Okay, we know that we have to now determine whether this is going to open upward or downward. We know that it's vertical, and the way that we do that is we look at whether p is positive or negative. So if p is positive, then we're going to have a parabola that opens upward. So what we're going to look at is that our focus then would be above, because our parabola is opening somewhere upward. Again, it doesn't have to be exact. Our focus is going to be above our vertex. How far above? 2 units above. So that means that it's going to be at the point 2, 3 plus 2, or 5. So again, the 5 we got from adding k to p. But if I didn't draw the graph, then I might make the error of adding it to the x coordinate. I also can see very clearly that if I subtract p units vertically, that I'm going to be having a directrix below the vertex. So the y equals 3 minus 2, 2 units below 3, so y equals 1. The only thing I haven't labeled on here yet is my axis of symmetry. Notice that if your directrix is an equation y equals something, then your axis of symmetry must be x equals something, in particular the x coordinate of the vertex and the focus. In this case, x equals 2. So we have all the information we were asked for. But let's just write it out. The vertex, which I'm going to call V, is the point 2, 3. The focus, which I'm going to call F, is the point 2, 5. The directrix, which I'm going to call D, is the equation y equals 1, and the axis of symmetry is going to be x equals 2. We have all the information that we were asked for, plus we have a nice little graph of our parabola. Now, if you really wanted to know how narrow or wide this parabola is, you can always plug in an x value and get a corresponding y value and use the symmetry just as before. I hope this video was helpful. If it was, please remember to like it so that other students can find it. And I will be posting some other videos on parabolas and other conic sections, so keep an eye out for those. By the way, thank you to my viewer who requested videos on parabolas, ellipses, and hyperbolas. If you have any questions, please feel free to leave them in the comments below.